All right, in this podcast, I want to show you an example of a problem that could be asked about entropy. Okay, so we have this equation up here, and then we're given the entropy values for NO and NO2, and it wants us to determine the entropy of just O2. There is one thing that I did leave off the slide that I should throw in right now. The total entropy of just this reaction, okay, the change in entropy, is negative 146.4 joules per Kelvin mole. Okay? All right, so you see we're going from 3 moles to 2 moles, so there is going to be a decrease in energy here. Okay, so we need to try to determine the entropy value for just O2. Okay, so we're going to do products minus reactants. We got 2 times NO2's value, which is 240.1. And that was all of the products minus the reactants, which are 2 times NO's value, which is 210.8, plus X, which is going to be our O. And it's all equal to negative 146.4. Okay, all right, so now we're just going to do a little math to get this simplified down a little bit. So we got 480.2 minus 421.6, and then we're just going to go ahead and distribute that negative sign on in and get negative X is equal to negative 146.4. All right, we're going to combine like terms on this side, so we get 58.6 minus X is equal to negative 146.4. And then last step, we will subtract the 58.6, get it on this side, and we end up with negative X is equal to negative 205, and then we need to inverse the signs to get the X positive, so we get 205 joules per Kelvin mole. Okay, so that is the entropy of just O2. All right, so now that we have the value for the delta S, we can go back and we can look at the equation here. Okay, so it wants to know if the reaction is spontaneous or favored. Well, when you're looking at the negative sign there, we know that two things drive a reaction: decrease in enthalpy and increase in entropy. Well, here we only have entropy values to look at, so we have to base it solely off of the entropy. And the entropy of the reaction is negative, which means that is going from more chaotic to less chaotic. And this is not favorable.